Hi guys, I wanted to share some notes and some helpful hints for how we are going to simplify radicals or square roots, as you guys all know them as we get into some more review concepts from last year. So if you look at the launch that I have up here, we would first start with the square root of 144. And like we've talked about before, this is when we're trying to figure out what number times itself gives us 144. And we know that that would give us the answer of 12. Okay? We also now, when we go to number 2, we look at and we see we have the square root of -5. Now, like what we talked about before when we worked with functions of square roots, we know we never can take the square root of a negative. So we know that if we ever saw the square root of -5, we would say no solution. Next, we have the square root of 0. And we know what number times itself gives us 0? It would give us 0. Now the last one we have is the square root of 40. And if we look at that and we think about what our perfect squares are, we know that there is not a nice number or a rational number that is multiplied by itself that gives us 40. We know that if we worked it out and we plugged in a calculator, we could get a decimal. But as you all know, it can't be that simple. So we're going to look at how we can simplify these square roots. And we call them radicals when they're not perfect squares. So we're going to work through exactly how we are going to simplify those today. So if you saw, we linked up a note card for you guys to use. This note card PDF will be a great resource for you guys to use as you are getting through this. These are the perfect squares of the first 15 that are really going to be helpful for you when you're simplifying radicals. So when we are looking at problems like that number 4 on the launch, or like this one here, the square root of 48, we know if we think about it, there is not a number times itself that'll give us 48. So what we need to do first, as it talks about over here, is we've got to find 2 factors that go into the number. Now, one of the most helpful hints for you guys to do is think about it as perfect squares. So it's really important you guys know your multiplication facts to work with this. So if you think about it, we know that 4 times 12 goes into there. We also know 6 times 8 goes into it. We also know 3 times 16 goes into it. 2 times 24. 1 times 48. The biggest thing you need to think about is you need to think about, of those factors, which of those is a perfect square. And the helpful hint we always want to give you is you always want to try to look at the largest one. Okay? So if we have the square root of 48 and we want to break it down, a lot of times you guys, we always think of 4 times 12. Well, we know 4 is a perfect square, which is great. We know we can take the square root of that. So what we will do is we'll put 4 and 12 under the radical symbol. Now, like I said, we know 4 is a perfect square. We know we can take the square root of this, and that then goes away, doesn't have to be under the square root. So we're left with 2 radical, still 12. But here's the deal. We know 12 can be broken down more. We have to always break the number that's under this radical down until it can't be broken down anymore. And we can break it down with 4 and 3 because, again, we know 4 is that perfect square. So again, if we take the square root of 4, we're going to take it and put it on the outside, which is a 2. Which gets rid of this 4. So by doing that, we now have 2 times 2 times the radical of 3. Because again, we cannot break 3 down anymore, so we have to just leave it under there. So now we're left with 2 times 2. We can simplify that, and we get 4 radical 3. There are also some other ways to do this, but right now we're just going to think about it as perfect squares. So again, like our steps over here say, you want to look for factors that go into it. 1 needs to be a perfect square. If neither of them are a perfect square, you're not going to be able to break it down this way. You want to take the square root of your perfect square. That number will always go on the outside. Okay? Once you take the square root of a number, remember, it doesn't go under the radical symbol. And you will keep breaking it down until the number on the inside is a prime number or has no perfect squares as factors. All right, so let's do some more practice problems here. All right, so if we look here at the example page, and if you look over here on the side, I typed up what our note card would look like if we were in class and we would have made it. But right now we can just use this, whoops, as that is a typo. That should be 9. All right, so if we look at number 1, we have the square root of 36. So if you are unsure if numbers are perfect squares, what I would tell you to always do is on your note card, you want to look down the right column. So the first thing you need to do is you need to look down here and see if 36 there. And since you see 36 is right here, and we go across, and that means that the square root of 36 is 6. All right, now if we go to number 2, again, the same thing. We got the square root of 49. So if I look down the right column of our note card, I look to see if I can find the number 49. And as I go down, I see 49's right there. And so I know that the square root of 49 is 7. All right, and number 3, the square root of 196. So again, if we look down the right-hand side of our column, I go down and I see the square root of 196, and I know the square root of that is 14. Now, if they're perfect squares, you're going to see that number exactly there. If they aren't, we're going to have to do some work. So let's look. Number 4, we've got the square root of 54. So if I come over to the note card, I look. And as I work down, I see I have 49, and then I jump to 64. So I know 54 is not a perfect square. So what that means we need to do is we need to now go through and we need to think of our factors. Okay, and there's a couple different ways to do this. If you know your factors right away and you know what two numbers can multiply to give you 54, great. If not, a helpful hint is we know we would be starting right here. You would be working your way up, and you can divide each of these by 54. By doing this, you're going to find the largest perfect square that goes in there, which is going to make it less work for you to do. So if I work through 54 divided by 49, doesn't divide evenly. 54 divided by 36, still doesn't divide nicely. 54 divided by 25, nope, still doesn't work. 54 divided by 16, still doesn't divide nicely. 54 divided by 9. Oh, I know 9 times 6 is 54. So I know that I'm going to make a square root symbol, and I'm going to write 9 times 6 underneath it. Now, what I know is I saw 9 on my table, on my note card. So I know I can take the square root of 9. What that means I'm going to do is take the square root, put that on the outside, and I know the square root of 9 is 3. So I know that that 9 then disappears on the inside because I took the square root of that. All right, so now I got to think about the 6 though. Can I break down 6 anymore? I know the factors are 1 and 6, 2 and 3. I know 1 is the only perfect square that goes into it, but it doesn't really change anything. So I know I am left with the answer of 3 radical 6. And that is how you would solve that. And that would be your final answer. All right, So now let's go to number 5. We've got the square root of 24. So I'm going to come back here real quick. Well, it's not letting me do that right now. So if I come and I think of square root of 24, I've got to think about what two numbers can multiply to give me 24. So if I look down that right hand side of the column, I go through and I see 24 is not there. If I was to work my way back up, 24 divided by 16 doesn't divide nice. 24 divided by 9 doesn't work nice. 24 divided by 4 works. So I know 4 times 6 gives me 24. Like we talked about, we know we can take the square root of 4, and the square root of 4 is 2. And like we talked about on that last example, we can't break down 6 anymore. So our final answer is 2 radical 6. All right, and number 6, we've got the square root of 40. Well, automatically going through, we know 40 is not a perfect square, but I know 4 times 10 will give me 40. So I don't even need to use the note card right now because I know 4 is that perfect square and I can multiply it by 10. So again, like we talked about, we'll take the square root of 4, which gives us 2. Now we think about it. We've got 10. I know we have 1 times 10 and 2 times 5. I know none of those are perfect squares, so my answer is going to be 2 radical 10. And number 7, I've got the square root of 75. We all should know, since it's 75, that that's one of those that's a multiple of 25. And I know 25 times 3. Gives me 75. And I know 25 is that perfect square. So I get 5 radical 3. All right. So those are a couple ways to think about simplifying radicals with note cards. All right. Now, there are a couple other ways that you can do these when you can think of doing the prime factorization. All right. Now, number 8, we can think about doing it with the prime factorization way. Oh, actually, we're going to scratch that. We're going to do it just the same way. So let's come back and let's do it the same way we look about. Now, 68 is a little bit tougher. If we go through, we know 68's not here. Now, as we're working our way up, we're finding that we can't really divide by any of these until we get to 4. And we know we can do 4 times 17. We know 4 is that perfect squared, so we get 2 radical 17. All right, so there you go. That's how we're going to simplify down radicals and square roots. Let us know if you have questions, and we hope you have a good rest of the day.